talking about black holes right here and white holes right there. And yeah. So white holes push matter out of it. Nothing can get in these white holes. Black holes, they suck things in it, and it never comes back. But one thing to know about black holes is you got to know what they are. And to know what white holes are, you got to know what they are. Before we begin, I'll talk about white holes and black holes itself. So white holes right here, we don't know if they're actually real yet, because there's still so many things out in the universe right here. So could white holes be real? These are just the questions of white holes. No one knows if they're real, but white holes actually can transform into a black hole. White holes can turn into a black hole. And if they were to fight, the black hole would win. This would happen. Vroom. So pretend this is the black hole. And this is the white hole. White hole would be smaller. And the black hole, wait one sec. Would be bigger. If we were to fight, this thing would win. The black hole. Because it it sucks it in. It destroys it. This is a picture of a real black hole. And this is a picture of a white hole that people have just designed. So yeah. So pretend. Yeah, so we talked about the white hole, not the black hole. Lots of people know about black holes. Black holes will just suck matter in faster than the speed of light. Let's get that. Yeah, faster than the speed of light. Nothing can escape it. Sometimes they can escape. But the black hole also has a little accretion disk swirling around it. Did you know that? Well, yes, because some light sometimes just gets caught in its orbit. Now, before you know that, you need to know what orbits are. And we're going to tell you right now, because you need to know what orbits are and how they're made. Orbits are when something gets close to it, it starts getting around it, swirling around it, like our sun. And this is the sun, and this is Earth. If it comes towards it, it will get pulled in its gravitational force, and will start swirling around it. Like that. That's what orbits are. Now you need to know how they're made before you know what black holes are. What black holes and white holes are. Okay. So pretend this piece of paper as a accretion disk. And if we can, not if we can. Why would I say that? Okay, so I did this so like it's getting cold, and I got a coin here. Yeah. And so now we're gonna walk over here and watch what happens when it goes on. Well, it's not heavy enough. Let me get something heavier. We'll just, if something goes on it like this, it will kind of make it go down like that. And and then if something like another coin or like this or like this gets near it, this will happen. If it gets near it, it will fall into that thing. Yeah. Look at that. Back on the black hole stuff. Black hole and white hole. So I'm gonna put the sun right here. Yeah, it's right on my hand. It's right there. And a black hole right here. And then watch what will happen. Didn't you hear that? Didn't you see that? Yeah, it was awesome. It makes a accretion disk. And now, yeah. And now, know what black holes are. But the black holes are awesome. And to make the gravity go, it has that by the mass. Black holes are massive. So if a star gets near it, since it's so massive, it makes a very deep hole, like we showed you back there. And well, that deep hole goes down like that. Things get attracted into it, but since it's so far down, it actually just makes it go into the black hole. Yeah. Cause it's so fast, it will make it collide and go into the black hole. Yeah, like that. It's awesome. Yeah. So like I'll show you if you still don't understand how gravity works, I'll do it again. Before I show you again about gravity, this is also how strong the gravity is. So pretend this is just space matter. If anything gets close to it, the gravity will break. So it just gets forced right into it because gravity can't make it swirl around. I'm going to clean that up. Okay, so I set up this. Yep, I got a controller here, and you can see what happens when I put this thing down on here. It went down. It float back up, went down, and then something else like this tape comes from right here, roll one in, then we'll roll it into that thing. That thing. The tape will go right in. And it could get stuck there. That's why when things are farther, not just against it. And also this. Like, this is my sister's toy. I have a sister. This, if that gets in it, that might be higher up. It's lighter. That might be higher up. But if it were to go in fast, this would happen. Go right into it. So let's see what would actually happen in space if this was in space. It would have went fast like this. That's that. So the closest planet to there, that's what happens with it. Yeah, it might slide. Yeah, that's why sometimes the orbits get all wonky donkey. Yeah. Yeah, now you just need now we're just gonna watch a video of black hole. Of a white hole right here. Of a white hole right here. And a black hole right here. Yeah. Okay, so we're gonna watch a little video.
Black holes haunt our universe. Dark centers of gravity that swallow everything in their path. What would you see if you got close and fell past the point of no return?
Time and space. They are fundamentally linked, like two sides.
Astronomers are always looking at the universe and discovering new planets.
The mass of the Sun is almost 2 octillion tons. That's 1.989 times 10 to the 27th power, which is equal to 99.8% of the mass of the entire solar system. It's simply unreal to imagine even a
Black holes are among the most fascinating objects in our universe, and also the most mysterious.
On January 21st, 2019, for the very first time, NASA's TESS saw a black hole destroy a star. This was a tidal disruption event, which occurs when a star passes too close to a black hole. Extreme gravity causes the star to bulge and break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the All-Sky Automated Survey for Supernovae, which first identified it.
That's a Chromebook. That's a Chromebook. That's a Chromebook. That's a Chromebook. Switch to Chromebook.
Black holes are some of the most powerful and violent objects in the universe. They can warp space and time and rip entire stars to pieces. So what if I told you that astrophysicists think there's one lurking in our very own solar system?
Then a new discovery rocked the astronomical world to its foundations.
Now, before you freak out, you should know that our planet isn't about to get sucked up and reappear in another galaxy. If there is a black hole, it's at least 20 times farther from Earth than the farthest planet, Neptune, in a distant region of our solar system called the Extended Kuiper Belt. The belt is home to billions of icy objects like comets and asteroids. And in 2016, astronomers Konstantin Batygin and Mike Brown noticed that some of them have highly unusual orbits. While most objects in our solar system orbit the same plane and in the same direction, the orbit of these objects looks like this. Some of them orbit on a slight tilt, others orbit backwards, and still others orbit perpendicular to the plane of our solar system.
Imagine the plane of the solar system as being your table. These orbits are stacked like pieces of books.
They concluded that this could mean only one thing.
In order to generate this population of highly inclined perpendicular orbits, you need some distant gravitational pull.
By their calculation, that gravitational pull is 5 times greater than Earth's. So they reasoned that this something was as large as a planet orbiting our sun. In fact, they even went so far to give it a name, Planet 9. Now, of course, if they were to confirm this discovery, it would be groundbreaking. The first new planet in our solar system since the discovery of Neptune in 1846.
Very little is known about Neptune, the last of the giants on this tour.
But there was a problem. No one was able to observe the planet directly. Now that could be because finding a planet that far away is like searching for a needle in a haystack, with the lights off, and only a vague idea of where the haystack even is. Or it could be because, well, that something is not a planet at all. In a study published in the fall of 2019, theoretical physicists Jacob Schultz and James Unwin proposed it could actually be a black hole. Not just any black hole, but a primordial black hole.
Primordial black hole is a remnant from the Big Bang that came from a very dense region that almost instantly collapsed into a small black hole right during the birth of the universe.
And they do mean small. About the size of a tennis ball. That's right, this black hole would fit in the palm of your hands. While the idea might sound far-fetched, it isn't totally out there. For over 50 years, astronomers have proposed the universe is littered with primordial black holes. And we've even observed fluctuations of starlight in our own galaxy, which primordial black holes could explain. Not only that, but Schultz and Unwin also noted that if a primordial black hole orbited the sun, it would have the same effect on objects in the Kuiper Belt as a large planet. But whether it's a black hole or a planet, there's another mystery. Where did it come from? One idea is that the object was wandering through the galaxy and got caught in the sun's gravity. But for now, this is all just speculation.
If we do our searches, and it turns out that there is a planet in the outer solar system, this would be an absolutely incredible discovery. Such a strange planet on such an odd orbit, it would really change our understanding of the history of the solar system.
But if it is proven that this is a black hole in our own outer solar system?
This is completely mind-blowing. And the fact that this not only would change our understanding